Good afternoon, everybody. In the last class, we discussed about the resource allocation graph. By using resource allocation graph, how we can detect the deadlock, right? And also, I mentioned some of the methods for handling the deadlocks. So here we can follow the three methods for handling the deadlock. First one is ensuring that the system will never enter into a deadlock state by using the deadlock prevention or deadlock avoidance algorithm. And second method is allow the system to enter into the deadlock state and then detect the deadlock and recover from the deadlock. And third one is we are ignoring the problem that the deadlock will never occur, or we'll pretend that the deadlock will never occur in the system. And this method is used by most of the operating systems including Windows and the Linux operating systems. So in this class, first we'll see which are the methods available, then we'll discuss in detail about the deadlock prevention algorithms, or how we can use the methods to prevent the deadlock. Right. As I said, we can make use of the deadlock prevention or the deadlock avoidance algorithm. So, in the previous class, I already explained that which are the necessary conditions for deadlock to occur, right? We discussed about four necessary conditions for deadlock to occur. What are those? Mutual exclusion. Second one is hold and wait. Third one is no preemption, and the fourth one is circular wait. So if all these four condition holds good, then only the deadlock will occur. If one of the condition is not holds good, then the deadlock will never occur. So we'll concentrate on these methods, how we can use these methods in order to avoid the deadlock, or how we can ensure that one of these methods will not be hold good. These methods we are discussing in the deadlock prevention algorithm. And in the deadlock avoidance algorithm, so here the operating system is given an additional information in advance regarding the which of the resources a process can request for, and which of the resource the process can use, and how many resources the process can use for its entire long time, or for its lifetime, right? If this information is given in advance related to the process, then the resources will be allocated or will be delayed whenever the process requests. So this method is used in the deadlock avoidance technique. And the next one is we will allow the system into enter into a deadlock state and then we'll recover that. So for that we'll use different deadlock detection algorithms, and we'll use the algorithms to recover from the deadlock. So first we'll concentrate on deadlock prevention algorithms, or methods to solve, or the protocols to be used to prevent from the deadlock. So as I already said that, so we have four necessary conditions: mutual exclusion, hold and wait, circular wait, and the no preemption. So first we'll see what is mutual exclusion, then how that can be avoided. So mutual exclusion, as I already explained in the previous class, that one of the resource should be in a non-shareable mode, or the resources are in the non-shareable mode. If the resources are in the non-shareable mode, then the mutual exclusion occurs, right? If we avoid that, means if we allow the resources to be shared among different processes, then we can avoid the occurrence of the mutual exclusion. So the best example is, let us consider a resource type file. So if the file is not shared among the different processes, then the process will enter into the waiting state, and then there is a occurrence of the mutual exclusion, right? But if we make the files to be shareable among different processes, because if that is in the shareable mode, then the whichever the process request for the file, they can use it. But whenever we are making the files in a shareable mode, then we can make that or we can make that the files are only in the readable mode, means all the processes can read the files. So because here we are making these files as the read only files, so that all the processes can make use of it, then we can avoid the mutual exclusion, right? So that is the case. But as we know that some of the resources cannot be kept in the shareable mode, because let us consider an example of a CPU that cannot be shared all the time between all the processes, right? So in such situation we cannot avoid the mutual exclusion, but for some of the resources, if we keep the resources in a shareable mode, then we can avoid the occurrence of the mutual exclusion. If it is avoided, then we can prevent the deadlocks. So this is the one method we are using for deadlock prevention. Understood? So what is mutual exclusion? Mutual exclusion means keeping the resources in a non-shareable mode, then mutual exclusion occurs. But if we keep the resources in a shareable mode, means the resources can be shared among the different processes. For example, files, if we keep the file as the read only file and that can be shared among different processes, then we can avoid the mutual exclusion. So that is for some category of resources, but some category, for some resources we cannot keep those resources as the shareable resources. So then in such extension in such cases mutual exclusion occurs, but that is not, that cannot be avoided and that is not in our control. Okay, but for some of the resources, if we keep them as shareable resources, then we can avoid the occurrence of the mutual exclusion. So that is about the mutual exclusion. Next comes the hold and wait. So in the previous class I explained what is hold and wait, and if that condition satisfies, then there is a chance that the deadlock will occur. Hold and wait means if one process is holding one resource and it is requesting for another resource, then we say that it is hold and wait. And if it is requesting for other resource, then that resource is holding by one more process and that continues, and the requested process will never get the resource, right? In such cases the hold and wait condition satisfies, then there is a chance that the deadlock will occur. So if we avoid that, if we will make use of the protocol so that it will avoid the occurrence of the hold and wait situation, and that is, here we'll use the method or the protocol that whenever the method is that, so whenever the process is requesting for the resource, then that process should not hold any resources. Means a process to request resources only when it has none. Only when it has none means the process should not have any resources, then only it can request for the resource. In such cases the resources will be allocated to the requested process. That is the one method. And the other method is before the process starts its execution, so the process can request for all the resources it requires during its execution. Then once the resources are allocated, then it can begin or it can start its execution. Once it completes, then all the resources it must release. So these are the two methods used to prevent the hold and wait condition. That is here it is there, right? The first one is this. So requires processes to request and will be allocated the resources before it begins or starts its execution. Once the resources are allotted, then the process can execute. Then once it completes its execution, then only it releases the resources. And the second one is, so one the requested process can be allocated the resources only when it has none. Means the process can request for resources only it doesn't have any resources or it doesn't holding any resources, then only it can request for the resources, then the resources will be allocated to this. So consider an example for the first case. First case means before the process starts its execution or begins its execution, it is requesting for the set of resources and the resources will be executed. The example for this is, let us consider that a process needs to copy the data from the DVD drive to the disk, and from the disk it has to print the content. So for that, how many resources are required for the process? One is the DVD drive, and second one is the disk to store the file, and third one is the printer. So these resources are required by the required by the process, right? So then in the first method, so the process is allowed to request for all three resources, that is DVD drive, disk, and also the printer. Then once all are allocated, then the process can execute, means it can copy the data from the DVD drive to the disk file, and then it can take the printout. That is the first method. So here what happens, even though the process is using the printer at last, but the resources are allocated at the beginning stage itself, then what happens, the resources usage or the utilization may be low. It leads to low resource utilization because we are using the printer, or the process is using the printer at the last. Even though it is using the printer at the last, but it is allocated in advance, or during the beginning stage itself the printer is allocated, then it leads to the low resource utilization. And in the second method, what happens, the process can allow to request for the resources only when it has none, means so consider the same example. So initially it is not having any resources, then the process is requesting for the resources. We'll consider the same example, right? So it is requesting for the resource, DVD drive and the disk. So it is requesting for the DVD drive and disk, and both are allocated. Once the data is copied from DVD drive to the disk file, then both the resources are released. So now the process doesn't have any resource, then once again it is requesting for the resource. What are the resources it requires? It requires the disk to get the file from the disk and to print. So it requires the printer as well as the disk. So second time it is requesting for the printer as well as the disk, so that it gets the data or the file from the disk and it gets printed by using the printer. So once the printing is completed, then it releases the resources. So in this method also it is leads to the low resource utilization, because only for one, that is just to copy the data from the DVD it uses that resource, and to copy the data into the file it is using that resource, then it releases the resource. Once again it is requesting for the resource, like that. So then what are the disadvantages of these two methods? One is low resource utilization, and second one is starvation is possible. And so starvation means what? That we already discussed in the previous chapter, right? During in FCFS or in the priority algorithm, starvation is possible. Means some of the process will never get the uh, chance for execution. Then we say that that condition is a starvation condition. Here, how that we can apply here? So here, whenever the process is requesting for the resources, if the resources are held by another process, then the requested process will never get the resource, then the process will never get the chance to execute, and that is called as the starvation. Because whenever the process is requesting for the resource, always that is held by another or some other processes, hence the requested process will never get the chance for execution, and then that leads to the starvation. Means some of the processes will never get the chance for execution, and that condition is said to be starvation. Understood? So here, but we can use these two methods in order to avoid the hold and wait situation to occur, right? Hold and wait means, so the process will hold one resource and requesting for the another the resource, and since the other resource is not yet allotted, then the process is in the waiting condition. So that can be allowed by using these two methods or protocols that I already explained, right? One protocol allows the process to request for resources, means whatever the resources required by process, all the resources can be requested by a process. Once all the resources are allocated to a process, then only the process begins its execution, right? And second one is, the process can request for resources only when the process doesn't have any resources, or it is not holding any resources. These are the two protocols are used to these are the two protocols are used for to avoid the hold and wait situation to occur. So this is about mutual exclusion and hold and wait. So which is the third characteristic for deadlock to occur? That is no preemption, right? No preemption means what? No preemption means once the process gets the resources, then the resources cannot be released from the process until it completes its execution, and that is called as no preemption. But if the resources are held by the process, and if the process is in the waiting condition, there what happens? Either the process will not complete its execution, nor the process will releases the resources. There is a chance that the deadlock will occur, because the other processes which are requested for the resources that held by another process will get the resources, then there is a chance that the deadlock will occur. So then how we can prevent that? So we can use the method so that it will prevent the occurrence of the no preemption situation. If no preemption situation will not occur, then we'll assure that the deadlock will never occur. So here, if a process that is holding some resource request, right, if the process who is holding some resource request, resources and request for another resource that cannot be immediately allocated to it, uh, then all the resources currently being held are released. Means what? So suppose, let us consider that the process P1 is holding some resources, understood, and it is requesting for some other resources, and those resources cannot be immediately allocated to process P1. Why? Because whichever the resources the process requested, those resources are held by other processes. In such cases, those resources cannot be allocated to the process P1. Then the process P1 will enter into the waiting state. So once the process is going to enter into the waiting state, then whatever the resources currently held by the process P1 are immediately released. Because P1 is entering into the waiting state, then it cannot complete its execution, right? Or it can start the execution. So then whatever the resources are held by that particular process P1 cannot be used. Hence, to avoid that, whenever the process P1 is entering into the waiting state, immediately the resources allocated to that are currently held by that process P1 are immediately released, and those resources will be allocated to other requested process. So in this case, what happens? Preemption we are performing, right? We are preempting the resources that are currently held by the process P1. Why we are going for preemption? Because P1 is requested for other resources where those resources are not immediately allocated to the process P1. Why? Because those resources are already held by other processes. Hence, the P1 is entering into the waiting state. So during the time, whatever the resources the process P1 is holding, those resources will be immediately preempted, means released from that process, and those resources will be allocated to other processes which are requested these resources. And this is one method. And second one is, whenever the process is requesting for the resources, then before allocating those resources, we'll check that in the table how many resources are available and how many resources are used by other processes, and how many resources will be requested by other process. By considering these, we'll allocate the resources to the request process immediately, or will delay that, so that we will avoid the no preemption situation. So here, as I said, once the preemption occurs, preempted resources are added to the list of resources, then so that those will be allocated to the requested process. Then the process, then what happens to the process which is in the waiting state? The process will be restarted, means the process which is in the waiting state will be restarted only when it can regain its old resources as well as the new resource that is requesting, that it has requested. Now let us consider for the process P1. Initially it holds the CPU, and it is requesting for the printer. If the requested printer is already allocated to other process, then that cannot be immediately allocated to process P1, right? Then the process P1 is entering into the waiting state. When it is entering into the waiting state, whichever the resource is currently held, that is the CPU it holds, right? Process P1 is holding CPU and it is requested for the printer, but the printer cannot be allocated to that. Then what happens? The P1 is entering into the waiting state. By that time, immediately will release the CPU that is held by process P1, and that released resource will be added into the list of resources, and that CPU will be used by the other requested processes. Now what happens to the process P1? The process P1 will be restarted only when it gets the previously holding resources, means it can regain its hold resources. Which are the hold resource? That is CPU, right? Process P1 is holding the CPU. So once it gets the CPU and also the requested resource, that is the printer, then only the process P1 can restart its execution. If it will not get, then it can never execute, right? The process will be restarted only when it can regain its old resources as well as the new resources that it is requesting. So these are the two protocols or two methods used in order to avoid the in order to avoid the no preemption situation. So one is what? Whenever the process is requesting for the resources, if those resources are currently held by other resources, then the resources cannot be immediately allocated to the requested process. Then all the resources which are currently held by the requested process are released, are preempted. Once the resources are preempted, they are added into the list of resources where those resources can be used by other processes. So then when the preemption occurs, only when the only when the resources which are currently held by the process P1 are requested by other processes. If no other process is requesting for the CPU, then the no preemption or the preemption will not occur. So the preemption will occur only when the currently held resource by the process P1 is requested by other process and no other CPU is available in the list of resources, then only the preemption occurs. Otherwise, and that resource will always with the process P1. That is the first method. And second method is, so whenever the process requests for some resources, first we'll check whether those resources are available or not. If they are available, then we'll allocate them. If the resources are not available, then we'll check whether those resources are already allocated to other processes where those processes are in the waiting state. If those processes are in the waiting state, then we'll release the resource from the waiting process and allocate those resources to the currently requested process. So these are the two methods used in order to avoid the no preemption situation. If we avoid the no preemption situation, then we are preventing the deadlock to occur. So this is one of the algorithm to used to avoid the occurrence of the deadlock. So the last one is the hold and wait, the circular wait. So first one is mutual exclusion, second one is hold and wait, third one is no preemption, and the fourth one is circular wait. So in the last class I explained what is circular wait. If we are considering the three processes P1, P2, P3 and three resources R1, R2 and R3. So P1 is holding R1 and requesting for R2, where P2 is holding the resource R2 and it is requesting for R3, whereas P3 is holding R3 and requesting for R1, where R1 is currently held by the process P1, and this situation is said to be a circular wait. If the circular wait situation is occurred, then we say that there is a chance of deadlock. So then we can avoid the deadlock, or we can prevent the deadlock by avoiding the circular wait to occur. So then how it can be avoided? So here, whenever we are having the set of resources, then for each resource we are assigning a unique integer number. So that is unique integer number assigned to each resource, and this number is assigned in the order of are arranged in increasing order of enumeration. For example, let us consider we have three resources: CPU, memory, and the file. Then for CPU we allocate the integer number as 1, and for the memory we will allocate it as 2, and for the third one, or if you consider third one as the printer, then we allocate the integer number as 3. Then the processors can request the resources in the increasing order. Means, the suppose let us consider the process P1 needs the resource. So first it has to request for the resource CPU, because it has got the higher number, that is 1. So that is the integer number 1 is allotted to the CPU. So first process P1 must request for CPU, then it can request for memory, and then at finally it can request for the printer. So once it is requested for the printer and once it is allocated to the requested process, then it cannot request for the memory or for the CPU, because whenever the process is requesting the resources, the integer number is compared, and only when the requested resource number is greater than the previous one, then only the resource is allocated. Otherwise the resource will not be allocated to the requested process. So for each resource which is existing in the system, for each resource we are allocating the integer number. Then it is a unique in nature, and whenever the process is requesting for the resource, the process must request for the resource only in the increasing order. So if it is not in the increasing order, then the resource cannot be allocated to the requested process. So in this way we can avoid the circular wait. Means, initially the process P1 is requesting for the CPU, where the CPU one has got the integer number 1. So first it will request for that, then it is requesting for the memory. So it is in the increasing order, because for memory we allocated or we assigned the number as 2. So once it is used, then it can request for the printer, that the number assigned to this is 3. So if it is in the increasing order, then only the resources are allocated. If they are not in the increasing order, suppose if at the first place itself, if the process P1 is requested for the printer, the integer number allocated to is 3, then it can never request for the CPU until it completes its execution, because it is not in the increasing order. So if we follow this method, then we can avoid the deadlock. So these are the 4 different deadlock prevention algorithms that can be used, so in order to prevent the deadlock. Okay, understood? So means we are avoiding the situation of mutual exclusion, circular wait, no preemption, and old and wait. If these are the 4 characteristics for the deadlock to occur, right? If all are holds good, then only the deadlock will occur. If one of the condition doesn't holds, then the deadlock will never occur. So in this way we are preventing the deadlock by not satisfying one of the characteristics of the deadlock. Means, if we are avoiding circular wait, or no preemption to occur, or the mutual exclusion, or the hold and wait, then the deadlock will never occur. So in this way we are preventing the deadlock to occur. So in the next class we are going to discuss about the deadlock avoidance. So what is deadlock avoidance, which are the algorithms we can use? So here they are given the example for deadlocks, so that we'll discuss in the next class. So how we can, are the this is a mutex example, and that we can discuss how we can use the mutex in order to avoid the deadlocks. That we'll discuss in the next class. And in the next class we are going to study about deadlock avoidance algorithms, how we can use the deadlock avoidance algorithms in order to avoid the deadlocks. And after that we'll go for deadlock detection and recovery algorithms. So this is about the deadlock prevention. So in the next class we'll see the deadlock avoidance algorithm, and after that we'll go for deadlock detection and recovery algorithms. Any doubt in this? If not, I'll stop my session here itself. If any doubt, you can ask. Any doubt? If no, then we'll close the session. Any doubt? If no, then I'll stop my session here itself. So in the next class, we are going to study about deadlock avoidance algorithms.